you should pause and see if you can apply Cramer's rule to this system of two equations and two unknowns. Okay, well, first thing we write down is the determinants that are going to give us the solution. The coefficient matrix has column 4, 5, 7, negative 3. The matrix on top is going to replace the x column, 4, 5, with the results of the two equations, the negative 5, 12. So we have determinant negative 5, 12, 7, negative 3. And those determinants are easily evaluated. Mainly interested in the scheme. Anybody can evaluate these determinants, some more carefully than others, and I screw them up occasionally. What about y? Well, it's the same scheme. If you understand the scheme, it's very straightforward to write it down. Here's your coefficient matrix, same as it was before, the x and the y coefficients. And then we replace the y column with the negative 5, 12. So we see the negative 5, 12 goes for the x, is substituted for the x column in the numerator of our solution for x, for the y column in the numerator of our solution for y. We evaluate the determinants. Negative 5 times negative 3 is 15, 7 times 12 is 84, 15 minus 84 is negative 69. I put pluses here because I skipped a step. The denominator is also negative, negative 47. So we have negative 69 over negative 47, which is 69 over 47. And the denominator, the solution for y, we do have a negative on that 47. And yeah, okay, that works. Okay. Evaluating the determinants is just straightforward. 48 here and minus negative 25 there gives us 73. Denominator is again negative 47. That gives us a positive 73 over negative 47, which is negative 73/47. And we can check. You do need to check these. You need to be in the habit of checking. Plug this in for x, this in for y. In the first equation, you're going to get negative 5. Do the same in the second equation, you're going to get 12. Now, next question is, okay, let's go ahead and do the system that I've got here, a system of 3 equations and 3 unknowns. Don't look at what I've got. Write down what you think the determinants will be. Fill in these determinants here. Don't worry about evaluating. Just fill them in the way you think they ought to, based on the pattern you've seen here. Don't look at what we've got here. Pause and do this. If you don't have it in 5 minutes, then look. Okay, well, hopefully you paused, but the situation is very similar, but we have 3 rows and 3 variables. So our coefficient matrix is going to have 3 columns. Okay, the 3, 4, 5 for the x column, the 5, negative 3, 2 for the y column, the negative 7, 5, negative 9 for the z column. To get the numerator of our solution for x, we replace the x column, which was 3, 4, 5, with 12, negative 5, 6, and then we just bring up the rest of the other 2 columns, the rest of the matrix, the rest of the array to here, so that we have something completely analogous to what do we have here. Replacing the x column of the coefficient matrix by the right-hand sides of the equations. And then we can evaluate these, but I haven't told you yet how to evaluate a determinant of a 3x3 determinant. Okay, for y we do the same thing. We just take the coefficient matrix, bring it up here, but we leave the y column blank, and we insert the 12, 5, negative 5, 6. That gives us our determinant for the y. Okay. Now, how do you evaluate a 3x3 determinant? Your book tells you, of course, but it helps if you see somebody point it out. We take first 3. Okay, we got 3 here in the first row. Now, what we're going to do is we're going to do what we call expanding in terms of the first row. Okay, expanding about the first row. We have 3 here. So we're going to write down the 3. And then we're going to eliminate the column below 3 and the row across from 3. We eliminate that column and that row. It leaves us with the 2 by 2, negative 3, 5, 2, negative 9, which is what we write here. So it's going to be 3 times the determinant of what we get if we eliminate the column and the row below and across from 3. So here we have it. Then we do the same thing with 5, except that we, on the second number that we use, we do a negative. Okay, so it's minus 5 times the determinant that we get if we eliminate, I don't know if I have a good way to do that, the row and the column of 5. So I'm kind of hiding that row and column, leaves us the 4, 5, 5, negative 9, which I write down here. And then it's plus whatever this number is times the determinant that we get if we, right hand doesn't want to do that. Okay, let's try this. We eliminate the row and column of the negative 7. It'll be plus negative 7 times the determinant of the 4, negative 3, 5, 2 that we have here. Okay? And that's the pattern. That's how we evaluate a 3 by 3 determinant. Of course, you need to expand that. And I attempted to expand these, and I made a bunch of mistakes doing it in my head. I don't even know if that's right. But you do it. It's not difficult. It's a little bit long. It takes a little while to evaluate these, and there are plenty of opportunities to make errors. But I will expect to be able to apply Cramer's rule to a 3 by 3 or a 2 by 2 system.